Good morning, everyone. Now I'm going to start the presentation. The topic is NLP, Natural Language Processing. By today's presentation, you will learn the basic concept of NLP. You will have a brief understanding about it, and you will learn what is the problem encountered by NLP, how we fix that. This includes traditional solution and modern solution, as well as its real-life application. Next, what is NLP? Natural Language Processing. If you search on Google, NLP is a subfield of computer science and artificial intelligence that makes computer understand human language. In simple words, natural language processing. Natural language means English, Chinese or Malays, we as a human speaks. Processing means how computers understand, read it, and use it to communicate with humans. Why is it important? Because computer only understands 0 and 1. It cannot directly understand human words. So this is where NLP comes in and helps. Next. This is a chart that shows the market size is growing over years. The market size of NLP is growing over years. That means a lot of technology companies like Microsoft, Google, Apple, they invest more and more on development of NLP. And it will be more important in the future. So
Alright. Now that we have a brief understanding of what NLP is, let's dive into the problem faced during the development of NLP. Next slide. Gen Z language. I'm sure you guys recognize these phrases, right? You are my sunshine. Hold up, let me cook. Sorry, you are not a Sigma.
Sigma is Gen Alpha, was famous word.
Yeah, I don't know, man. Anyways, why do you guys understand these phrases? Because you guys know the context behind them. That is why you guys know their intended meaning. Well, I would like to ask Ms. Shangita, do you understand what hold up, let me cook means? Okay, no response. She doesn't. Hold up, let him cook. Do you understand what it means?
Does it mean that let him just say his part or whatever he want to say and he's picking up some story?
It means he's about to do something incredible. Let's see what he does. Let him cook.
Correct.
Okay. So yeah, you have some understanding.
I really want to know what's Sigma though. I want to keep singing this song.
That's we'll leave that for another day. Okay, so Ms. Shangita doesn't know what Sigma means because she does not understand the context. Just like a computer, it cannot understand context. And that is why we need NLP. Because with NLP, we are able to understand the context behind human language. Alright, next slide.
Okay, the you are my sunshine, damn racist.
Really?
It's not. It's dedicated to LeBron James. But anyways, other examples of context-dependent scenarios. We got Gen Z slangs in general, idioms, sarcasm. Wow, I love this food so much. Okay, figurative language, and ambiguity in language. This means words that has multiple meanings, like watch. It could be seeing, watching, or like the device watch. That's ambiguity in language. Alright, moving on.
We have multilingual and code switching. What is that? It's an alternation between two or more languages within a single or utterance, conversation, or document. Why is that a problem? Because computer can't.
Cannot hear. Come to the middle.
Okay.
Speak louder.
Okay, let's restart this. multilingual and code switching. What is that? It's an alternation between two or more languages within a single authored conversation or document. Why is this a problem? It is because the computer can't understand the human text and languages. Example of multilingual conversation, you see this picture, later we go mama, her cha, and ChatGPT say, won't understand and respond. Next.
Now I'm going to explain briefly how NLP works. Next. This is how NLP works since 1980, where the concept of NLP just started. First of all, if we want computer to understand human language, the first thing we do is set the rules to the sentence of text or words that we want computer to understand. It's like in our middle school or elementary school English lesson, we must learn grammar. We must learn the sentence structure in order to understand English. Same goes to computer. We set grammar rules. For example, if I write a sentence, I eat apple, computer will know I is subject, it is verb, apple is object. This is called grammar rules. In NLP, this is called syntax. So this is one of the rules. Other than this, we have sentimental analysis, where computer will identify the positive or negative of a word. For example, I write the word happy, computer will know it is a positive word. If I write the word hate, it is a negative word. And other than this, we have entity recognition. Computer will identify the entity of words, like dog is an animal. If I write 3rd September 2025, it is a date. So it recognizes the entity. And next, rule application. Literally just apply the rules we set to the input data. Rule processing. Computers produce output according to our instruction, like summarize, extracting text, or translating. Rule refinement means we improve the rules we set at the first step by updating it. Why we need to do that? Because the rules we set at the first are not actually perfect. Computers can still make mistakes, misunderstanding about human words. Like Chinese just say, cook can be cooking food or just another meaning. So AI can easily make a mistake. So we need to update the rules constantly. But here it is the defect, because every time update means the researcher need to manually rewrite the rules, which this is slow, lag efficient, and even the latest rule cannot cover every cases. So this is why we need a more automatic solution. Next, which is machine learning. So instead of manually updating the
I
rules,
dive in more deep.
machine learning allows computers to automatically improve itself by learning from examples, learning patterns from data. So it learns example, also known as training data. It comes from online source like customer reviews, movie reviews, news article or web page. It collects data. After it collects data, it will try to understand it, read it by identifying the frequency of positive words, negative words. If a positive word is more than negative words, means the article it reads is a positive. And if a negative word is more than positive words, means it is negative one. So basically, this is how AI model is trained. The more data you feed to AI model, the more accurate it is, it gets better as long as it is trained. So these are the advantage of machine learning compared to rule-based, what I explained just now. Machine learning, it can handle large amount of data automatically without researchers to manually update the rules. Adaptive, it can quickly learn from new examples, and there will always be more examples in the future. So it can quickly learn from them. Next. Machine learning can be divided into two types, supervised and unsupervised.
Fake.
Supervised machine learning,
Four
it
types.
learns from input and output, like answer,
Yeah,
question and
that's the
answer.
problem. There's
So
actually four
that
types.
next time, if
Supervised,
you ask a
unsupervised,
similar
supervised,
question,
and
you will
reinforcement
answer
learning.
back with correct answer. Unsupervised machine learning,
And unsupervised learning is basically there's
it
four
focuses
more
more on
stuff they
its
did not list
ability
down.
to classify text, identifying the entity of words, like cat and dog is animals. It's not a vehicle.
And NLP basically
Mechanic,
uses
doctor is a
supervised
human,
or
not a
reinforcement
tools.
learning. More simple terms.
Move on to next.
So we have the statistical machine translation. The first one we have is translate a sentence into another language. Second, apply standard NLP tool. Third, may have translation error plus loss of meaning. So we have the early statistical machine translation (SNT) in the translation in the early days. And you look at this image. How does SNT translate a sentence? We have English output, I will love. And then you compare to German output.
We're doing this next week, bro.
And this is the German output. Next.
Us until 10, not
Now moving on to modern solutions. Next slide. In modern solutions, we use deep learning based method. Deep learning based method is
basically
split into
reinforcement
main two
learning.
parts.
This is basically
One is
reinforcement
recurrent
learning.
neural networks and the other is convolutional neural networks. Let's talk about recurrent neural networks first. What is recurrent neural networks? Oh my god. It is a neural network that processes sequential data. Next slide.
Mm-hmm.
What is sequential data? Well, sequential data can be normal English sentences. John
That's
threw
why
the
I told
ball.
you it's
You can see that it
reinforcement
is
learning.
arranged
Reinforcement learning
in
is a bit
an
like,
ascending order. 1, 2, 3, 4.
Sequential data.
If we were to use the same exact
I'm
words,
gonna ask the question.
John threw the ball, and rearrange it somehow. The ball threw John, for example. These two sentences, John threw the ball and the ball threw John, they both have completely different meanings, even though they use the same exact words. This is sequential data, data where sequence and arrangement matters. Next slide. Now, this is recurrent neural networks in action. This experiment is conducted by me. It is from the Google autocomplete function. Here, I typed in break a. I'm intending to type in break a leg, but it was able to predict break a leg meaning. Have you guys ever wondered how does that work? How does it produce this prediction?
Algorithm.
Algorithm, yes. Alright, let me talk more about that. Wait, sorry. Why does this occur? Why does it not give you another prediction? Like, it could be anything. It could be break a glass, break a window, break a piggy bank. Why break a leg meaning? Break a sweat or anything else? Because it uses the most frequently occurred search results, frequently occurred sequence of words, and use that as the prediction. So break a leg meaning, it has been occurred many, many times. That is why it is prioritized and used as a prediction. Okay, alright, let's see how it works under the table. Next slide. This is RN architecture. I will break it down for you. This circle right here, it is equivalent to a memory cell. It stores information, it stores previous input. That is how you remember stuff and remember the context. Now, this right here, it is the input. It is the things that I typed in the searching bar. Break up. Now this square thingy is, I would call it a brain. It's like a brain because it does all the computation and it produces a prediction. Now I won't go into detail for this because it's basically a mathematical equation and it does a lot of very complicated calculations, so I won't cover this. Now, after all the computation, it produces an output prediction, or we call it as date. We type in break up, it results in date. Now, why is it like this? Why is it? We call it as a cycle. This is like a cycle. Why? Why is it a cycle? Because the more inputs, as we type in more words, it would result in more predictions, different predictions. Say if I were to type in the whole complete idiom, break a leg, it would still produce a prediction, like break a leg meaning, break a leg in Chinese, break a leg in Japanese. Those are the predictions that it could produce. So that is why it is a loop, a cycle. Moving on.
Supervised. Okay.
Yeah.
Alright, thank you now for introducing us to RNN. Now I'm going to talk about convolutional neural network CNN. It is based on text classification and sentiment analysis. Next. It also converts from unstructured data to structured data. Next. How does it work? This picture may seem complicated, but it's okay. Mine is here more. Okay, first, a user will input a sentence into it. I'll just use I love apples as an example. Alright, now the convolution layer will start doing its job by separating the words and classify whether it's a noun, verb, adjective, or so on. For example, I and apples are a noun, and love is an expression. Then, the convolution layer will start their sentiment analysis. How does it? Wiesen have already mentioned what is sentiment analysis. It's basically just like analyzing if the word is expressing positive feelings, neutral feelings, or negative feelings. So for love, it's positive feelings. I don't think I have to explain why. Then, after analyzing these, the pulling layer will start doing its job by highlighting the important features. As I and apples does not express anything, so love will be the only highlighted point. Alright. After the pulling layer highlighted the point, the doing his job by connecting all the highlighted
Why?
features.
Shit.
Lastly, they will just generate an output of it. That's how CNN works.
I would want to
Alright,
present in round
for-
3, not gonna lie.
For the second model method, we have transformers. It is a large language model
Get me done, bro.
from multilingual language used by the transformer architecture. Now, what is transformer architecture? Anyone knows? Transformer architecture is an AI model that understands and generates human-like text. An example for transformers, we have multilingual verb. It supports up to 104 languages, and it also translates in a higher speed and accuracy. Next. You guys must be wondering, how is it better than RNN? Because its function is almost the same, but transformers can do even more. What can they do? Anyone knows? Yeah. They can do text summarization, image captioning, and speech recognition. Next. Alright, that's more for our model methods. Now we're moving to application. Next. First, we have machine translation. As you all know, Google Translate, I don't know, some translate apps. Yeah. So how does it function? I will just show it on the board. Let's say you want to translate dog to Chinese. Okay. Then the machine will start doing their job by searching all the data related to dogs. It's like the character from another language, such as go, inu, anjing, blah blah blah. Yeah. And then the system will analyze, will like determine which character is the language that the user wants to translate, which is Go. In case if you all know Chinese is Go. Yeah. Lastly, they will just generate the output as Go. Will be their final answer. Okay. Second application, we have chatbots and virtual assistants. I guess you all are very familiar with this because ChatGPT, Siri, Alexa. Yeah, it enables human and robots conversation, so you can just chat with it when you're bored. Next. Furthermore, we have email filtering. If you guys have opened your email, you will see tons of categories such as primary, social, spam, blah blah blah. Yeah, those are because NLP help them sort it out by analyzing the text. Moreover, we have predict text. I don't know if you all have this setting when you type on keyboard after one character, it will predict a few word option for you all to choose. Yeah, this is also the help from NLP. And finally, we have summarization. Maybe you guys are very lazy to read a long paragraph. You can just throw it to ChatGPT and the NLP will help them summarize this paragraph. And that's all for application. Moving on to my next colleague.
So, the conclusion here next.
Oh my god.
First, we have an enhancer global computer. Firstly, it can help people to interact with different languages around the world. Second, it can be a smoother international collaboration to other people countries around the world. Next. Second, we have the time and cost efficiency. We save time and resources. Second, it can help to translate all amount of the languages in machine translation. Lastly, efficiency.
I have an evil
save
thought.
time cost to heavily invest in professional language translation. Next. Third, we have the rapid language learning. Okay. It can.
Feels so
It can help to translate unfamiliar language to
It's recorded. Yes,
the
it is
another
recorded.
language in the world. Next.
Alright, so this is Chang Ziquan.
This is Aniru.
This is Peter.
This is Isaac.
And this is NLP.